Okay, so for numbers 69 and 70, they ask for the multiplicity of each of the zeros. And in order to find the multiplicity, we have to look at the degree of the factor from which that zero comes from. So the first thing that you need to do is you need to make sure that your polynomial is factored. So in number 69 and 70, both of the polynomials that they give us are factored. So we will just immediately set each of the factors equal to 0. Technically 3, because it's being multiplied by x plus 8, is a factor, so you would set that equal to 0. Then you would set x plus 8 quantity squared equal to 0, and then the x minus 8 to the third power equal to 0. Now, from the 3 is equal to 0, there is no x to solve for. 3 is never equal to 0, so that is not going to give us a 0 of the polynomial. Now, this x plus 8 quantity squared, you could sit there and take the square root of both sides, but the reality is every time you have it already factored, it's just whatever is inside of that parenthesis that is going to matter. Because when you do take the square root of both sides, you'll get x plus 8 equals technically plus or minus 0, but plus or minus 0, the sign is just going to be nothing, so we'll have 0. So really, when I look at this, I don't even think about like taking the square root. I just say, okay, whatever's inside the parentheses, that's what I'm setting equal to 0, and I get x is equal to negative 8. And then, of course, over here for our second actual x involvement, we'll have x minus 8 to the third power. So we set this x minus 8 equal to 0. We get x is equal to positive 8. So these two numbers, negative 8 and 8, because they come from where those factors are equal to 0, those are the zeros of the polynomial. And remember, when we were talking about the zero of a polynomial, we're really talking about the x-intercept. So you can think these are the zeros, or you can think that they are the x-intercepts of the graph, where y is equal to 0. So this question then asks for the multiplicity. So the multiplicity is the degree of the factor that you have. So the degree of this polynomial is not 2. But when you look at this x is equal to negative 8 and you trace back where that came from, it came from this factor and it has a degree of 2. So we would say the multiplicity associated with negative 8 is m is equal to 2. Now, over here with the x is equal to 8, if we trace back to the degree from which that came from, that was 3. So our multiplicity would be equal to 3. Now, the reason why we care about multiplicity is it does tell us the behavior of the graph at the x-intercept. So just for like for your information, when your m is equal to 2, if at any time it's even, what that means is that it will touch and turn at that x-intercept. So what this is telling us when we get m is equal to negative 8 is that at negative 8, we touch and turn around. And we might touch and turn around above the x-axis, or we might touch and turn around below the x-axis. We don't know until we start plugging in numbers and seeing what is positive or negative for y. But the idea is there's going to be some touch and turn at that x-axis because it is even. And when the multiplicity is odd, then you are going to cross the x-axis. Namely, there is going to be a sign change that happens at the 0. So when we talk about crossing the x-axis, we mean that it's going from negative to positive, or it might be going from positive to negative, but it is going to slice through the x-axis at that x-intercept. So for this question, the key thing is to remember that we factor, set each of the factors equal to 0, and then our multiplicity is the degree of that factor. So here the degree was 2, so m is equal to 2. Here the degree of that factor was 3, so m is equal to 3.